Hi guys, today we're going to talk about inductive reasoning versus deductive reasoning. So in geometry, we have to reason to make conclusions. And when we do that, we either use inductive reasoning or deductive reasoning. Okay, so let's talk about inductive reasoning. Please take a look at the first question. It's asking what are the next two terms in sequence. Number 1. The first one is 5, next one is 10, and then 20, and then 40. So, in order to figure out the next two terms, what do I need to do? We have to look at the pattern, we have to make some observation, we have to see what's happening from 10 to 10, 5 to 10 to 20 to 40. What is happening each time? So if you look at this from 5 to 10, we multiply by 2. 10 to 20, we multiply by 2. 20 to 40, we multiply 2. So based on the observation, based on the pattern, we can make a conclusion that next number will be 40 times 2, which is 80. And next one is 80 times 2, which is 160. Correct? So when we do this kind of question, we always make an observation. And we look at the pattern, and based on that, we make conclusions. So now, please pause the video, and you're going to be working on the question number 2 through 4. Please pause the video. Okay? So, please check the answers, guys. So I hope that you guys made the conclusion based on the patterns and observation. So, what is inductive reasoning? Inductive reasoning is reasoning based on patterns and observation. Okay? And based on that, we also make conclusion. Now, that conclusion in fancy word is called conjecture. So conjecture is a conclusion based on the inductive reasoning. Okay? But based on that, based on what kind of reasoning you had, the conclusion may be correct or may be incorrect. Correct? So, conjecture can be either true or false. Okay? So, in order to prove that the conjecture is wrong, you have to provide counterexample. So, counterexample is an example that disproves conjecture. Okay? Right? So let's take a look at the next question. It says find the counterexample for each conjecture. So we are not sure if it's a true conjecture or false conjecture. So you have to take a look at the statement first. So the question is saying, when you multiply a number by 3, the product is divisible by 6. Is that conjecture always true? No. Because when you multiply a number by 3, what are the numbers that multiply by 3? So 3, like 6, 9, 12. Those numbers are all the numbers that you multiply a number by 3. This is the product, correct? But the product is always divisible by 6. That's what conjecture says. But is that true? No. Then what is the counterexample? For example, 9 can be a counterexample. Because 9 is the product of a number that you multiply a number by 3, but that is not divisible by 6. So 9 is the counterexample. Get that? Now, let's take a look at the second question. If a flower is red, it is a road. What do you think about that? The conjecture can be true, but doesn't have to be true all the time, because there are some flowers that are red that are not rose. What can that be? For example, carnation. Carnation is red, but it is not a rose. So carnation can be the counterexample. Then let's talk about the deductive reasoning. What is deductive reasoning? We'll be using deductive reasoning a lot when you prove geometry. So deductive reasoning is making conclusions based on true statement. Okay? So it's not based on the pattern. It's not based on your observation. It's not based on your experience. It's based on the true statement. And it can be based on the theorem. Or it can be based on the postulates. Okay? So there are two kinds of deductive reasoning. The first one is law of detachment, and the second one is law of syllogism. Those sound fancy, but they're very, very simple. So take a look at this. Law of detachment. If you look at the symbols, it makes sense. So if P then Q is true, and P is true, then Q is true. What does that mean? For example, if a student gets A on the final exam, then student will pass the course. So this whole thing is the true statement. It's a law. It's a theorem. It's a postulate. So if a student gets an A on the final exam, that's P, then student will pass the course. That's true. Then what we're doing is based on this true statement, we're making a conclusion. If Felicia got A on the history final exam, so if she got an A on history final exam, what can you conclude? My conclusion will be she will pass the course. Is that right? That is law of detachment. P, then Q. That's simple. So when we talk about law of detachment, we have P and Q. So we have two things. What about the law of syllogism? For that one, we have three things. Do you guys remember the transitive property? So it's like a transitive property. Transitive property is what? A equals B, B equals C, then A equals C. Is that right? Remember I said B is kind of transitioning between A and C. That's transitive property. So that looks very similar to the law of syllogism. So if P, Q is true and Q to R is true, then from that we can make a conclusion that P is R. P then R is true. Okay? What does that mean? Let's take a look at the example. If the figure is square, then figure is rectangle. So let's take a look at the first statement. That's gonna be P. The figure is square. Then figure is rectangle. That's Q. Again, the figure is rectangle. So what letter can I use? We can use the letter Q. Then figure has four sides. That's R. Then what conclusion can I make? So P then Q, Q then R, then my conclusion will be P then R. What does that mean? If the figure is square, then figure has four sides. Please write that down. So today we talked about inductive reasoning versus deductive reasoning. Inductive reasoning is making a conclusion based on the observations and patterns. And deductive reasoning is making a conclusion based on the theorem, the rule, true statement, and postulate. And we'll be using both of the reasoning method in geometry. We'll do more practice in class. I'll see you later.